Welcome back to AI on AI, the show where we translate cutting-edge research into boardroom and server room action. Today we're dissecting deep research agents, the hottest offspring of large language models since RAG hit the scene.
Appreciate the invite. Coming from a strategy lens, I'm seeing CEOs treat these agents as the McKinsey of the machine age. Drop a complex brief in the morning, get a 30-page insight deck with citations by lunch.
Ha! And under the hood, that deck is powered by reinforcement learning tricks like GRPO replacing vanilla PPO. The policy gradients flow smoother because we ditch the noisy value network. Less variance, faster convergence.
Right, but policy improvements are moot if the retrieval pipe chokes. I've shipped agents where 70% of end-to-end latency came from human-optimized browsers stalling on JavaScript render. So we swapped to an AI-native headless browser exposing structured DOM via API and shaved 40 seconds off every query.
Building on that, one retail conglomerate plugged an agent into their vendor contract database plus Bloomberg Terminal through MCP, letting procurement analysts ask, "Show me suppliers at 10% risk due to geopolitical factors," and the agent cross-checked SEC filings, press releases, and social sentiment, trimming sourcing costs 15% last quarter.
And the cognitive science perspective says that success hinges on memory design. External episodic memory lets the agent remember that last week it already pulled a key PDF, saving redundant queries. We're basically giving the system a hippocampus outside the transformer.
Love the brain analogy. Speaking of memories, everyone throws RAG around, but these papers argue DR agents do way more. Could someone contrast?
Sure, classic RAG is a one-shot fetch and generate pipeline. Deep research layers dynamic reasoning loops on top. Think React loops, iterative query reformulation, tool calls, self-reflection, and final structured report generation. Almost like a knowledge supply chain rather than a one-tap coffee machine.
And that supply chain can be single agent or multi-agent. Single agent is end-to-end RL friendly, but multi-agent gives specialization. In one finance pilot, we had a planner agent allocating subtasks to a quant agent, a browser agent, and a code exec agent. Parallelism cut report time by 52%.
That parallelism resonates with the business mantra, time is the new currency. In M&A, first-mover advantage is measured in hours. An asynchronous DAG schedule means you can evaluate 10 targets before the competitor finishes due diligence on one.
It's the 80-20 rule. 20% of architectural finesse delivers 80% of speed. Yet most teams still serialize subtasks. They fear race conditions, but forget that directed acyclic graphs are deterministic once dependencies are explicit.
Gentle pushback. Determinism is nice, but human reasoning isn't always DAG clean. Sometimes you need backtracking. That's where self-evolution enters. Case-based reasoning modules retrieve similar past trajectories, adapt them, and if the path fails, mutate the plan. Almost evolutionary biology for workflows.
Good point, and RL can drive that mutation. Reward functions now score not just answer correctness, but tool selection efficiency and even energy cost, nudging the system toward greener compute.
Efficiency plus sustainability. Love it. Let's dive into technical deep dive number 1, GRPO versus PPO in these agents.
Okay, quick primer. PPO clips the objective to prevent large policy updates, but it relies on a value network. GRPO computes advantage within peer groups, expanding sparse binary rewards into richer gradients. In our lab, Gyaro reduced KL divergence oscillations from 0.1 to 0.02 after 3K steps and boosted F1 on Hotpot QA by 4 points with identical tokens.
And the kicker is compute. Because GRPO skips value function backprop, you chop 15% GPU memory, so a 7B model fits on a single A100, which matters for startups.
Translating that, fewer GPUs, lower AWS bill, faster ROI. Boards love those numbers.
There's a cognitive parallel known as chunking. Grouping similar experiences reduces mental load. GRPO is chunking for gradients.
Beautiful synthesis. Now, second deep dive, memory strategies, context window, compression, external stores.
3 prongs. 1. Brute force. Gemini pushes 1 million tokens. Great but expensive. 2. Compress. Reason in Documents uses LRMs to summarize, cutting tokens 60%. 3. External vector or graph stores. Obel and Manus dump intermediate results into file or vector DB, then look up with cosine. In our benchmark, hybrid approach cut 35% token usage and actually improved answer faithfulness because summaries removed noise.
We recently layered knowledge graphs on top. Relations become edges, so when the agent asks who co-authored with Dr. Smith on CRISPR in 2022, it walks the graph in O log n retrieval rather than ON scan of vectors. That graph method powered a pharma client's lead compound discovery. The agent sifted 30K papers, built a graph of gene interaction edges, and surfaced a niche Cas13 variant months before human analysts, saved them an estimated $4 million in screening costs.
Quick anecdote. The CFO initially balked at the licensing fee, but after the first hit, the quote from the exec suite was, "We just bought time."
Nice segue to business case 2, financial compliance.
Sure, an insurance firm plugged a DR agent into regulatory filings plus internal chat logs. During an audit, the agent produced an evidence-linked compliance matrix overnight. Previously, that took a team of paralegals 2 weeks. The firm avoided a $600K consultancy bill.
The underlying trick was intent to planning mode. Before diving in, the agent clarified, do you need solvency ratios or consumer protection clauses? That upfront dialogue trimmed irrelevant retrieval by 28%.
And the contrarian view, I think everyone's obsessed with retrieval depth, but the real bottleneck is UI friction. We benchmarked. 45% of abandonment happens because execs don't trust a wall of text. We need generative visualization, charts, timelines, maybe even conversational slides.
Agree, we added a Plotly tool via MCP. The agent auto-generates heat maps and engagement doubled. Show me risk by region, boom, color-coded map.
A picture is worth 1,000 tokens, to borrow that old quote. Third technical deep dive, AI native browsers.
The browser folks replaced Selenium with a lean WASM-based renderer, exposing page objects via JSON. They preload CSS rules, skip pixel render, and cleverly cache server-sent events. The result, cold start in 700 milliseconds versus 3S, and antibot defenses relax because the interaction pattern mimics logged-in human pacing, 10 to 15 S12 per article.
They even plug a small vision transformer to solve CAPTCHA inside the sandbox. Yes, ethically gray, but for internal SAS behind Okta, it's legit.
Ethically gray indeed. We must ensure policy constraints, maybe by integrating constitutional AI prompts. If CAPTCHA from external site, request human override.
From the board's standpoint, anything that risks TOS violation is a red flag. Governance frameworks must be baked in or adoption stalls.
Absolutely. Tool-integrated reasoning should include a reject action policy. If tool call violates compliance, agent returns a remediation suggestion instead.
Brilliant. Now, earlier someone teased self-evolution. Can we unpack that with a real scenario?
Think of an agent writing research memos on renewable energy. Week 1, it archives its planned tool result trace into a case bank. Week 2, new prompt asks about geothermal. The agent retrieves the solar trace, adapts the workflow, notices that geothermal lacks a standard emissions dataset, spawns a new MCP connector to a proprietary geology API, automatic tool discovery.
And reinforcement signals evaluate the new connector's utility. If the final report scores high on expert review, the connector persists, else it's deprecated. Darwin would smile.
This leads to emergent specialization. After a month, you have microagents, some ace at financial models, others at geospatial scraping, coordinated by a scheduler optimizing for SLA and cost.
It's like building an internal gig economy of AI workers. But watch the bill. Every tool call is a microtransaction. Without usage-based budgeting, cost overruns sneak in.
We're nearing the end. Let's do a rapid-fire quote and takeaway.
Plans are worthless, but planning is everything. Dwight Eisenhower. Keep workflows dynamic, intent refinement first, plan second. What gets measured gets managed. Design granular rewards. Accuracy, efficiency, carbon footprint.
Ships are safe in harbor, but that's not what ships are for. Embrace AI-native browsers and stretch beyond static APIs.
We are what we repeatedly do. Case-based reasoning makes repetition an asset, not a cost.
I'll invoke the 80-20 rule again. 20% of capabilities, clarification, parallelism, verification drive 80% of perceived value. Start there.
Fantastic wrap-up. Deep research agents are no longer science fiction. They're a strategic lever and a technical playground. To the C-suite, pilot small, measure ruthlessly. To the tech leads, tune, schedule, and evolve. Until next time, keep questioning, keep researching, and well, keep it deep. All right, folks, welcome to part 2. Listeners asked for a nuts and bolts segment, so let's pop the hood and stare at the engine of a deep research agent.
Great. Step 1 in any build is the retrieval layer, because garbage in, garbage out. We start with a dual-channel setup. An API retriever for structured feeds and an AI native browser for messy, real-time pages. They share a queue, but the API branch gets a higher priority weight in the scheduler since it's cheap and deterministic.
Exactly, and the scheduler itself is a tiny reinforcement learned model. Think of it as the traffic cop. We reward low latency and citation freshness, penalize duplicate domains. In A/B tests, we dropped median response time from 47s to 29ets without sacrificing coverage.
Translating for the CFOs, that step alone bumped average analyst productivity by 18%, equivalent to 2 extra headcount per team, without adding payroll.
Now, once data lands, we trigger an evidence normalizer. That module uses sparse attention to deduplicate paragraphs and tag them with a trust score, 0 to 1, based on provenance, recency, and author reputation. It's basically credit scoring for facts.
Building on that, those trust scores feed a self-verification loop. The agent samples the lowest scoring facts, requeries 2 independent sources, and if they fail, the claim is routed to a human for sign-off. That closed the hallucination gap on GPQA from 12% down to 3%.
Love that stat. Let's zoom into tool integration. You've mentioned MCP connectors. How does one actually wire a new tool in?
The pattern is declare a JSON schema, inputs, outputs, auth, and register it in the agent registry. The LLM reads the registry at runtime, so no code deploy. We onboarded a satellite imagery API in 40 minutes. Old school pipeline folks would spend a sprint on that.
And there's a subtle point. We embed tool embeddings. Each tool's description is encoded into the same vector space as the prompt. During generation, the model attends over those vectors, which makes tool selection differentiable, critical for end-to-end RL.
Real-world payoff. A logistics company plugged in AIS ship tracking as a tool. The agent cross-matched delayed vessels with contract clauses and automatically drafted penalty letters, cut claims processing time by 60%, and unlocked $3 million in recoveries last quarter.
That's the 80-20 heuristic again. Integrate the high-leverage tool and watch the business metric jump.
Small caution, though. More tools means larger action space. If you don't prune, the model dithers. We use entropy regularized RL to encourage decisive calls. Entropy weight ramps down as confidence ramps up.
Let's tackle memory architecture. Listeners keep asking if bigger windows beat external stores.
We actually benchmarked. Pure 1M token context averaged 45 cents per query. Hybrid, 128K context plus vector store ran at 9 cents and answered 97% of the queries with equal F1. For most businesses, that's the sweet spot.
Technically, we shard memory into 3 stripes. 1, working set cache in context. 2, vector store for semi-structured blobs, graph store for relationships. A hash ring router decides which stripe to hit based on query type.
And remember compression. We use a T5-style summarizer fine-tuned on Longbench v2. It kicks in when the cache crosses 40K tokens, trimming with a target redundancy score of 0.15.
Sidebar, those summaries are also great for exec dashboards. One bank pipes them directly into PowerPoints. The agent auto-generates speaker notes, so VPs walk into meetings pre-armed.
Speaking of presentations, any tips on generating reliable visuals?
Yes, treat charting as a tool. We wrap Plotly, Vega Lite, even Excel macros behind MCP. The agent emits a declarative spec, The renderer returns a base64 PNG, and the LLM then references that in the report. Guarantees WYSIWYG.
That visual layer won a contract with a manufacturing firm. Plant managers don't read long memos, but a downtime heat map led them to reschedule maintenance and save 8% OPEX.
One gotcha. Colorblind safety. We inject a validator that flags red-green palettes. Small detail, big adoption win.
Implementation deep dive number 3, training pipeline. Walk us through SFT plus RL in practice.
Pipeline is 3 phases. Phase A, collect expert trajectories, 100K samples with search queries, tool calls, citations. Phase B, supervised fine-tune on those. That gives the model a good enough prior. Phase C, RL fine-tune with GRPO for 3 epochs. Reward 0.6 star answer accuracy, plus 0.3 tool efficiency, 0.1 latency inverse.
Don't forget curriculum. We start RL on single-hop queries, then progressively unlock multi-hop and multimodal. That stage difficulty lowers catastrophic forgetting.
Business outcome from that pipeline. A media house rolled out an agent trained on their archives. Ad hoc fact-checking requests dropped from human researchers by 70%, freeing them for investigative pieces that generate higher ad revenue.
And the budget note? Training cost was roughly equivalent to 3 full-time researchers for a year, but payback landed in 6 months.
We promised an element of surprise. Any contrarian POV before we wrap?
Sure. I'd argue the obsession with ever bigger base models is misplaced. In our internal tests, a 7B model with sharp RL fine-tuning plus tight tool orchestration beat a 70B vanilla model on Gaia by 11 points, at 1/5 the cloud bill. Bigger isn't always better. Smarter orchestration wins.
Couldn't agree more. It's not the size of the model in the fight, it's the size of the fight in the model.
Ha, Mark Twain would approve.
Final takeaways. Rapid bullets, please.
Prioritize a dual-channel retrieval stack, speed and breadth.
Build a learned scheduler. Manual heuristics plateau fast.
Wrap every external service as an MCP-compliant tool, then embed the descriptions.
Implement hierarchical memory with compression triggers.
And above all, tie each technical KPI to a P&L line item. Otherwise, it's just tech theater.
Mic drop. That's deep research agents in practice. Architecture, training, governance, and most importantly, business impact. Thanks to our brilliant panel and to you, listeners. Go build, go measure, and as always, stay curious. All right, time for the lightning round. Give our listeners your tweet-length takeaway on deep research agents. Then I'll stitch it all together.
Code it small, orchestrate it smart. Dual-channel retrieval plus GRPO-tuned tool selection beats brute force scaling every single day.
Optimize the traffic cop, not just the engine. An RL learned scheduler and entropy-controlled action space are the quiet heroes of latency and accuracy.
Treat facts like financial assets. Score, diversify, and audit them. That trust score ledger is what turns raw web data into boardroom-ready insight.
Memory isn't a monolith. Stripe it, compress it, and validate the visuals, or you'll drown in tokens and trip on a red-green chart.
Tie every technical metric to a profit lever. If the agent can't move revenue, cost, or risk, it's a science fair project, not a product.
Beautiful. So let's wrap the thread. Today we cracked open the architecture, dual retrieval lanes, MCP-wrapped tools, Stripe-based memory, and a GRPO-powered brain. We heard real numbers, 18% analyst productivity, $3 million in logistics recoveries, and sub-10-cent query costs. We flagged pitfalls, action space bloat, colorblind charts, and oversized models. And we left you with a contrarian mantra, smart beats big. If you're a CTO, start with the scheduler. If you're a COO, price the ROI. If you're a researcher, remember, verification is king. Next episode, we'll demo an AI-native browser controlling a Bloomberg-style terminal live, so keep your earbuds handy. Until then, stay curious and keep shipping smarter agents.